This is Mr. Herman with your next Edpuzzle video. Our topic today is key features of graphs. So we're going to start with a few definitions, then also look at each of them as we go through, some examples of what those look like. So our first definition is the x-intercept, and that is when the graph crosses the x-axis. When we cross the x-axis, that also means that our y values equal 0. And so we're going to compare that with our y-intercept, which is when the graph crosses the y-axis, and that also means that x will equal 0. Okay, so those might be some review from previous years. So we will go ahead and look at a graph in a table. So for our graph, we'll start with the x-intercept. So the x-intercept is where we cross the x-axis. That's our horizontal one, left and right. And so here is our x-intercept. And the x-intercept there is at the point 1, 0. So notice how the y value is 0. Think back to when we graphed points on remediation. Okay, and then we look at our y-intercept, so our horizontal axis. We go up 1, 2, 3, 4. There's our y-intercept. So there's x, there's y, intercept. So we have 0, 4. Okay, so notice how the x value is 0. If we look at our table here, we'll start with our x-intercept. So a common mistake here is our x-intercept. We think that it's when x equals 0. The x-intercept is when y equals 0. So right there, that is our x-intercept. So there we go. X-intercept is 4, 0. Okay, now when our x value equals 0, that means that our y value is our y-intercept. Okay, so we'll have a couple of questions on intercepts. Now, after we've done intercepts, we're going to move on to reading a graph because we're looking for intervals of increase and decrease. So first off, when we read a graph, that means that we are reading from, like we read a book, from left to right. Okay, now simply enough, interval of increase is when our graph goes up and right. Interval of decrease then is when our graph goes down and right. It's important that we're always going to the right. Always going to the right when we read a graph. So here's our example. Now I'm going to track this graph as we go along from left to right. I just want to emphasize this is an arrow on the end here. Okay, so here we go. We're going to start right here. Now as I follow the graph, it's going down. It's decreasing, 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 decreasing. It stops decreasing. So right here, over this interval here, my graph is decreasing. Okay, so now we're going to start the graph again from here. As I go to the right, I'm increasing, 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 stop. Okay, so here is my increasing part. And then we got to finish it off because we've not covered the whole graph yet. And I go to the right, and I'm going down, so I'm decreasing. So there's my decrease. So I have 2 intervals of decrease, 2 intervals of increase, or 1 interval of increase. So when we write those intervals, we do it just like we did interval notation before. When we did our, number lines, and domain and range. So for decrease, on the left side, we started at -2. Okay. And then on the right side, we went to 0. Now notice how those are my x values. On intervals of increase and decrease, I'm always using x values. So make a note off here to the side. Use x values. Okay. Now, what I'm going to do at this point, since it's a dot, it becomes a bracket. Since I'm turning right here, I have to have a parentheses. Okay, now my increase. Parenthesis, 0, because I start increasing at 0. And we're increasing until we get to x equals, looks like about 4. Okay, now since that's a turning point of my graph, I'm going to use a parenthesis again. Now my decreasing start with my x values. My x values start decreasing at 4, and that means it's going to go down forever. You know that forever means we got to have an infinity symbol. Okay, now we have parenthesis here, and like we saw with domain and range, whenever we have infinity, we always have to have a parenthesis. Okay, now I just want to do a little quick review for interval notation. We kind of just touched on it, but if we have a dot, we want to use a bracket. Okay, point is included. If we have an arrow, we use parentheses. Point isn't included. And as we just talked about, includes negative infinity and positive infinity. Okay, just a quick review of interval notation. Now, once we talked about interval notation, these points here that I said we have to have parentheses at, those are important points to consider. Okay, now we might have put names to them before, but the names that we're going to use is a maximum, okay, or a max, the highest point on a graph, and the minimum, which is the lowest point on the graph. What's called a min. Okay, so you got the same graph right here. Okay, so I'm going to go ahead and go along my graph, and we have a minimum. So here's my lowest point right here. So I'm going to call that a minimum. And then let's see what point that is. That's at point 0, 1, 2, 3, 4, negative 5. Okay. Now I'm tracking my graph. Here's the highest point. Okay, so that's going to be called a maximum or a max. And then that point is at 1, 2, 3, 4, 5, 6. It's a little bit different than the first graph. And then up, what is that? 1, 2, 3, 4. A max at 6, 4. Okay, so minimum is the lowest point, maximum is the highest point. So we talked about 3 features: intercepts, intervals of increase, decrease, and minimums and maximums. Now what we're going to do is we're going to put all of those together, and we're going to take what we know from that and sketch our own continuous graph. Now continuous means that it's going from left to right. It doesn't stop in the middle. So we got 5 bullet points here that we're going to follow. So I'm going to try to color code this for us so we can see what's going on. So let's go. Let's see what we got first. We got starts at point -4, 3 and ends at point 5, 2. So I'm going to put those points on my graph. 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 4. 1, 2, 3. So about here. So I'm starting, and we end at 5, 2. 1, 2, 3, 4, 5. 1, 2. Okay. So there's where my graph starts and stops. Let's take a look. At red, has a y-intercept at y equals -3. Okay, let's come to our graph. Y is -3, so that means x is 0. 1, 2, 3. All right. Has a maximum at -2, -5. Or not a maximum, minimum. Sorry. Let's see. 1, 2, 1, 2, 3, 4, 5. All right. Somewhere in that ballpark. And then we increase from -2 to 3. Now, we got to be careful with that increase, because that increase is x values. Okay. So I like to make a note down here. From -2 to 3, we're going to increase. Okay? So, now I can do pretty much anything that I want to with this graph now. As long as I keep in mind I start here, I end here, this is the lowest point, and we cross here. If this is my increase, that means I probably have to have my graph go somewhere up here. Okay, so I'm not going to, since it's continuous, that key idea there, that means it's not going to stop in the middle. So I'm going to take my graph, connect my dots. There's my minimum lowest point. Intercept, cross through the axis. I'm increasing, 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 stop increasing at this point. And so then I'm going to decrease down to here. Okay, so that graph then fulfills all of the properties that we listed. It starts at -4, 3, stops at 5, 2. It has a y-intercept at -3, minimum at -2, -5, and it's increasing from -2 to 3.